Hello everyone, welcome to another kinetic tutoring episode. Today we're looking at another circular force equation, centripetal force equation, where we have a person rotating in a small circular room and we're finding the coefficient of friction needed to keep this person stuck to the wall and prevent them from sliding down. So let's take a look at the prompt. On the rotor ride, the passengers stand against the wall of a small circular room that spins in a circle. The radius of the room is 5 meters. When the room is spinning fast enough, the floor drops down and the passengers stick to the wall. The period of the motion is 0.77 seconds. What must be the minimum coefficient of friction between the wall and the passenger if the passenger does not slide down? So, first thing you're going to want to do in this problem and most of our force problems is to just draw a free body diagram. And let's draw, here's going to be our wall. So this is going to be our person. We drew them as a dot here. And the person's facing away from the wall towards the center of rotation. It's going to be somewhere over here. And let's draw the forces that are acting on this person. We know we have the gravitational force mg going downwards. We know that there's going to be a normal force exerted on the person by the wall. And we know that there's going to be a frictional force which is keeping the person from sliding down the wall. Now, since the prompt reads that the person is not going to be sliding, that means that the acceleration in the y direction is going to be equal to 0. Meaning that the forces are going to cancel out, and in other words, this simply means that our frictional force is going to be equal to our gravitational force. So let's write that out. Ff is equal to mg. Now let's take a look at our forces acting in the x direction. We notice that the only force is going to be our normal force, and what we also notice is that the normal force is always pointed towards the center of rotation, which makes this a centripetal force. So we can write our N as the centripetal force equation, the net centripetal force equation, which we know is mv squared over r, and that's just simply going to be N. Now, what we're going to do from here in order to make these two correlate is we're going to write our frictional force in its regular form, which is mu times n. We find that mu n is equal to mg, and then we're going to simply plug in our value of n. We get that mu mv squared over r is going to be equal to mg. From here, we can cancel out the m's, and let's find this equation so it's just mu is equal to everything else. You multiply by r, divide by v squared, and you get that mu is gr over v squared. Now from here, the last tricky part is going to be finding our velocity, deriving it from the period of motion. Basically, what the period of motion means is how long it takes for the person to complete one complete revolution and return to their original position. So basically go in one complete circle. And the way we're going to do that is by finding the distance they traveled and dividing it by how long it took. So we get our velocity in meters per second. We know that the perimeter of a circle, which is how far this person has traveled, is going to be 2 pi times the radius of the circle, which is in this case 5. 2 pi times 5 is going to give you 10 pi. So our velocity will be 10 pi over how long it took, which is 0.77 seconds. This is our v. As you can see, all we're going to have to do here is find this g times r, where we know that g is approximately 10, r is 5, giving us a value of 50 on top. Find this value here, square it in order to get our denominator, and we will find mu. So from here, it's all going to be calculator work. So let's just do that really quickly. 10 times pi will give you somewhere around 31.4 divided by 0.77 will get you something around 40.8. Now, we're going to square this velocity, which will be 40.8 times 40.8. This gives us a value of around 1,664. So that'll be your v squared. And our final step is to divide 50 by 1664. 50 divided by 1664 will give you a value of somewhere around 0.03 will be your mu coefficient of friction. And you must keep in mind that friction does not have a unit, so we're just going to leave our answer at that. I hope this helped, and make sure to tune in later for more physics tutorials.